The LS Electric Phox DC Servo from Automation Direct has very flexible control options. It can be utilized in position modes with traditional pulse train inputs, internal indexing, or various EtherCAT control functions. It also features a complete set of speed and torque command and limit options available via analog input or EtherCAT. Let's take a look at doing the basic setup for a Phox DC Servo. In this video series, we will start by wiring up the motor and drive. Part 2 will cover software setup and jogging the motor. And in Part 3, we will provide an overview of basic motion for a two-position system using push buttons. For Part 1 and Part 2, we will leave the motor uncoupled from any load for safety during initial setup and testing. This is always a good idea, regardless of what your final application is. Throughout this series, please refer to the Quick Start Guide available at AutomationDirect.com. It condenses key information from the LS manual into an easy-to-use format, while the full manual remains the best resource for detailed technical reference. I am setting my system up to run off of 120 volt AC. Because this servo system uses DC input, the AC is converted to DC using a 24 volt power supply for the drive power, a separate 24 volt supply for drive controls, and appropriate circuit protection and terminal blocks. The Phox drives support 24 to 80 volt DC power input, ideal for battery powered or mobile applications, with a performance reduction seen below 48 volts. Since motion is involved, an emergency stop is also included and wired through a safety relay to interrupt the drive's safe torque off or STO circuit. For this setup, we're using the 3 amp Phox DC drive, a 100 watt braked motor, and the corresponding encoder, brake, and power cables. While the drive supports third-party motors, using motors available from AutomationDirect.com enables full access to our free award-winning technical support and online resources. We're also using an STO cable, an I/O cable, and a feed-through terminal block to allow push-button control. We have already installed all our incoming feed power, wiring, and terminal blocks, and we've mounted the drive to our test plate using 2 self-tapping screws. We also have a length of DIN rail mounted and ready for the drive's I/O feed-through terminal block. As we begin wiring the motor, note that there are 3 connectors. The connector closest to the shaft is the motor power connector, followed by the brake connector if you have one, and then the encoder connector. All 3 come protected from the factory with small rubber boots. The cables for each connector may have a small piece of clear tape protecting the pinouts and securing the O-ring seals during shipping as well. Be sure and remove that if present. Let's wire the power cable first. This connector is keyed so it can only be attached in the correct orientation. Remove the rubber boot and place the power cable onto the connector head. Align the small screws in the cable head with the holes on the motor connector, and gently press the head down until it's fully seated. Then tighten the screws. Do not over-tighten, as the screw heads are small and easily stripped. Next, if you have a braked motor like we do here, connect the motor brake cable. This connector works almost identically to the motor power cable. Remove the rubber boot, confirm you are using the correct brake cable part number, and attach it in the only orientation available. Again, take care not to over-tighten the screws. And finally, we'll attach the encoder cable. Remove the rubber boot, then take the encoder cable and lightly press it onto the connector. It is key to install only one way, and you will notice a small cutout to assist with orientation. Press gently until it is fully seated, then tighten the 4 screws. Again, do not over-tighten. For the drive side connections, we will start with the encoder since it's pretty straightforward. Plug the 2 small battery connectors together on the cable so the system can support absolute mode if needed. Then connect the encoder cable to the drive connector labeled Encoder A. Once seated, tighten the 2 screws to secure it. While the system is fully functional with the motor encoder alone, the drive also offers the Encoder B connection. This is only necessary if you need a secondary encoder for closing the position loop on the drivetrain nearer to the load. For the motor brake cable connection, plug the 4-prong quick disconnect into the drive. Then connect the 2 24 volt DC leads to the positive and common terminals on the control power supply. These are polar sensitive, so ensure you don't connect them backwards. For the drive's motor power connection, use the green plug-in terminal block provided with the drive. It handles both the incoming DC power and the motor wires. This connector can only be installed one way, however you must land the various wires into the correct terminals. With the screw heads facing you, place the green motor ground wire in the far left position. The red U wire next, the white V wire after that, and the black W wire last. Verify the wire labels match the printing on the side of the drive. Next, connect the 24-volt DC drive main power wires from the power supply to the 5th and 6th positions for HV plus and HV minus. If you are using auxiliary power like we are here, connect the 24-volt DC control power wires from the control supply to the last 2 positions for aux plus and aux minus. Double-check polarity on all connections by referring to the drive label. In our example, we needed 24-volt power for the digital I/O functions anyways, and it's always a good idea to separate main drive power and control power whenever possible. Once everything's tightened and verified against the drive label, reconnect the green terminal block into the drive. Be sure to also connect the drive ground to the ground terminal block at this point. Even during basic testing, an ungrounded system can be unsafe and may cause irregular behavior. Avoid unnecessary risk in troubleshooting by properly grounding the drive using the ground lug located at the bottom of the heatsink. Looking at the drive now, the only connections we haven't made are the STO, I/O, and 2 EtherCAT RJ45 jacks. We aren't using EtherCAT for this example, so we'll leave those alone. We are using I/O, so now we can install the pre-made I/O cable and terminal block into the drive's I/O terminal. Mount the terminal block onto the DIN rail next to the drive and land the other end of the cable. Another option would be to use the pigtail cable if only a limited subset of wires is needed, or you want to use your own terminal blocks in your enclosure. We are also using the STO function with our emergency stop. You can use the crimp pins and blank STO connector that ship with the drive, but for only a few bucks more, it's much easier to use the pre-terminated STO cable. They come in various lengths, and we strongly recommend that any motion system use a safety relay in conjunction with these STO terminals. Plug the terminated end of the STO cable into the drive's STO connector. Then land the STO 1 and 2 wires on the normally open dry contact outputs of the safety relay. Beware of the wire labels. They appear to be heat shrink tubing, but they are not. If you must cut the small wire tie holding them together, ensure you don't allow those labels to fall off the cable. If you do, the 2-dimensional drawing available from AutomationDirect.com has the wire colors and pinouts on it. Finally, connect the COM wire to the common of the power supply you are using for the 2 STO circuits. In our case, that is our control power supply. And that's it. Let's try powering everything up by flipping the main circuit breaker for our incoming power. This powers up both supplies, and the safety relay turns on its power LED with its K1 and K2 LEDs indicating that everything in the emergency stop circuit is wired up correctly. Let's press our E-stop, and we see the K1 and K2 LEDs go out, indicating that it has entered a safe state. Then pull the E-stop back out, and they automatically reset and come back on. And we will run a quick meter test to ensure everything is within the correct voltage range. And it is. Let's power up our power and control circuit breakers to send power to the drive, and we see nothing trips. If we look at the other side of our test setup, we can see the drive LED is flashing red, which indicates the drive is booted successfully and there is an error. I'll give you a little spoiler into the second video and tell you that this is perfectly normal, as the drive doesn't have a valid encoder configuration yet. But more on that in the next video. One final touch will be to put a mark on the motor shaft. I'm going to use a permanent marker, but a piece of tape would work as well. Since these small motors don't have keyways or flats to give us any indication of orientation or movement, this mark will help us see the motor motion throughout our build. We have now fully wired our incoming control and drive power, motor power, encoder and brake connections, STO interrupt system, and I/O board. We have also conducted our power-up checks and are ready to connect the drive to the computer for configuration and jogging. If you need further assistance with your project, contact our free award-winning technical support team. If you want to take a look at the Phox DC Servo lineup, click here. To see part 2 of this series, click here. To subscribe to our YouTube channel, click here.